Okay, welcome back students. So we have here question 5 2022. I've put in the marks 5, 10 and 5, and I've just included here after reading the question that when we know that the diameter is 6, then we know that the radius is 3 centimeters. Okay, so we're asked to show that the volume of one full cylinder of air is 180 pi centimeters. You can treat this as calculate the volume, because that's the best approach. We'll calculate the volume and we'll end up with the same answer. Okay, so we go to our tables and we look up area and volume, which is very early on, up around page 10. Okay, open it up, and here at the top we have a diagram showing a cylinder and two formulas, one for the curved surface area, not the top and the bottom, and then the other one for the volume. So we write down this formula from page 10. Volume equals pi r squared h. Pi r squared h. Okay, now we'll sub in the values that we know. Pi we'll get from our calculator, r squared will be 3 squared, and h is 20. So we'll use a multiplication symbol because we're going to use it in our calculator now. Okay, and we'll fill this in, and it doesn't ever matter what order you put things as long as you use a multiplication symbol. So start with pi, multiply it by, you might fill in 9 now, but I'll fill in 3 squared just because I don't want to lose anybody, and I'll multiply by 20. Okay, I'll hit equals, and it says 180 pi in centimeters cubed. So we've given the answer in terms of pi. And we got that. Okay, so you've just shown your formula, you've shown the calculation, and the job is done. You don't need to say anything. Dara is inflating a balloon in the shape of a sphere. When fully inflated, the balloon has a radius of 15 centimeters. We can represent that sort of here. Find the volume. Okay, back to our tables. And the bottom thing here represents a cylinder. Okay, and our formula for the volume of a cylinder is 4 over 3 pi r cubed. Okay, we write the formula down. 4 over 3 pi r cubed. So we have to calculate. It said give your answer in terms of pi. Okay, in centimeters cubed, and these are centimeters. So we're just good to go here. We've got our 4 over 3 again. What we'll do is we'll take this little fraction bar and just extend it along. Okay, pi, and then 15 cubed. Okay, so it's a fraction. It starts with 4, and again I'm going to, the multiplication symbol is the simplest, safest way to make sure you don't throw up an error in your calculator. That doesn't mean you have to write it here in your page, it just means you should put it here in your calculator. Now on this calculator I have a cubed button. If not, if you're using the newer calculator, Casio in their wisdom decided to throw away the cubing function, so you'll be doing pretty much the same thing here. You'll be multiplying by pi, which we've moved up here behind a 7, and you'll be multiplying by 15, and you will need to use the general powering button. The general powering button, and take a power of 3. Okay, over 3, with shift equals there. Do the same thing here, and shift equal. Okay, so no matter what calculator you use, you get 14137.166. And give your answer. Silly me, I filled in the pi and I knew there was something wrong. So now I need to get rid of that pi. How am I going to do that? I'm going to jump back in here. No, not. Jump in here. And delete out that pi and that multiplication symbol and hit equals. And the answer is 4500 pi. So I wanted to talk you through what just happened. Yes, I made a sort of a mistake. I forgot that I was doing it in terms of pi. But I didn't check the marking schema to realize I was wrong. I went back up to look for what degree of accuracy they wanted, and then I was reminded that the answer should be in terms of pi, and then I went in and edited on my calculator to get rid of the pi. Okay, again, you should know that even experienced teachers make mistakes and struggle and go through problem solving skills, and that's why I'm leaving this video intact. Okay, we can put centimeters cubed here though, and that's great. So Dara pumps the pump once every second. So one of these blocks of air, one of these will go into this once every second. So you can see that you can just divide the 180 into 4500. That's probably what the question is going to be. How many seconds will it take? So every second is a full, so it's a dividing or a fraction question. So we can go 4500. I can either leave in or take out the pi. If I put it in, it's going to come out again in a second by cancellate. So they cancel. The two noughts cancel. And we'll do 450 over 18. Fraction bar 450 over 18. Okay, which is 25. So it'll take 25 seconds. Finally, Gustav is inflating a bigger balloon in the shape of a sphere. He also pumps the pump once every second using this fellow. His balloon is fully inflated after 50 seconds. Find the radius. So first we're going to find the volume. So 50 multiplied by 180 pi. We won't touch the pi here, we'll just do 50 times 180, which is 9,000 pi, is his volume. Find the radius of Gus when it is fully inflated and give your answer correct to one decimal place. So then we're going to come along here and go 4 over 3 pi. Let's use capital R just to say that we're using a larger radius than before. So the pi's cancel, the 3 comes up here because we're isolating R cubed. The 3 comes up and the 4 goes down. Okay, so that's equal to R cubed. Now how do we inverse operation cube? You may recall it's this one, the cubed root. Where can we find it? Well, on this one here, it's behind the square. It's here behind the square root. Okay, I don't think we're going to even find it on this one without using a general. There's a general possibility here. So, but before we jump into that, let's finish up the maths bit. So, let's firstly just let's multiply this out. It's let's just get this down to a clean number. So it's 20. Let's work it out. The calculator. 3 times 9,000 all over 4. It'll still be an integer, 6750. So R cubed equals 6750, which implies R equals the cubed root of 6750. Okay. So if I have that on my calculator and I want its cubed root, I will go shift cubed root. Cubed root of what? Cubed root of answer. Okay. Over here. I'll start off with the index of the power, which is 3. That's the number that goes there. and then I'll do my shift second function, and now I can fill in 6750, and I don't need to do shift equal because it's going to bring it to a decimal anyway, and I'm getting my same. I might have pushed return again on that, I probably did. Let's do that. 6750. Yeah, I think I applied it a second time and it ended up getting the cubed root of 18.89. Yeah, anyway, so that's it. Or capital R equals 18.898. I always like to write that down before I go off and check for the degree of accuracy they're looking for, which is one decimal place. So we're talking about what's happening here. Now what's happening here, I'm putting an arrow up here. Otherwise I don't put anything there if it's not going up. Either this digit either increases or doesn't increase. In this case it does increase. Now the hardest thing of all is when that causes a knock-on effect, and that can be quite difficult. But not in this case. So we have that the radius of Gustav's cylinder is 18.9 centimeters. That's it, folks. As always, I will see you in the next one.